We're now going to take a look at cranking systems testing and service. What to be looking for when we end up with problems. So number one is anytime we're looking at the cranking system we have an issue, always check the batteries first to make sure that they are decent so that we eliminate that from the rest of the circuit. Next thing is understand how the circuit is set up. And some simple checks that we can make before we start getting too carried away, because usually it's something simple that's happened. So again, when we're going in and checking the batteries, since we've already discussed batteries, I won't spend too much time on it. We all know how to load test a battery and make sure that it's functioning properly. So open circuit voltage should be approximately 12.6 volts. When we're loading it down, we don't want the voltmeter to go below 9.6 on a standard day. As the temperature gets colder, it's allowed to go lower. When we're testing batteries, again, we have to make sure that we separate them and test each one individually. Specific gravity, again, what we're allowed and if we have to adjust for the temperature. So once we've done test one and we've ensured that the batteries are good, we can go through the system and check to see what type of current draw we're getting through the circuit. Now, anytime we're doing voltage drops or checking some of the stuff, we want to make sure that the power is flowing. But on these basic tests, what we're checking for here is as we're cranking over, is what are we getting for voltage? So this one here, we're going to get, let's just say 12.6 volts. So the batteries are fully charged. As we're cranking it over between our B terminal and our M terminal, we should have 0. Now we're allowed 0.2 volts on the positive side and 0.2 volts on the negative side and 0.5 volts overall. So when we check from the M terminal to the ground, again, when this is cranking over, we should have very little voltage because it's all being used up in the motor. Now, we can use a carbon pile to simulate a load if we have one. We don't need to crank it over. One of the things that happens is if we keep cranking over, eventually we're going to deplete our batteries. So by using this to simulate a load, we can check a voltage drop between the positive of the battery and the positive of the starter. We can also check from the ground of the starter back to the ground of the battery, and that's going to tell us what our voltage drops are. So if we have an issue, we can fix that. It may not even be the starter. Now again, if we have two sets of batteries, we have to check each one individually, so we eliminate both sets of wires. And we had one on one of our trucks. It used to do a switch up in Golden every night. And it would start down here fine, but once it got up to Golden and sat for 5 or 6 hours waiting for the switch to come over, when he went to start it, there was an issue. So brought it back, tested the batteries were fine, but as soon as we went to load test the two separate sets of batteries, we had a voltage drop of 11 volts. So when we went back and started checking one of the wires, we found that the wire had rubbed through on the plastic battery case and there was only probably 20 strands left. So that was what was causing the high resistance in that circuit, so it wouldn't start. Once we fixed that, we never had an issue with it again. So this is why it's important to separate the two batteries. The other thing we can do is we want to check our start circuit also to see if we have voltage drops across there. And by taking the S terminal off and using that to simulate a load, again, be very careful that we don't load it up too much, otherwise we'll burn up the wires. But what we're doing is off of the battery terminal on the starter and our power on our start solenoid, we're checking for a voltage drop in there. We also want to check off of this side here to where our S terminal goes into and see if we have a voltage drop there. It may be a fair distance away, or it may be fairly close. Now, how we do these circuits again, going through and checking, because all of these here, we could have an issue. Now, if we hear our start relay go click, it means that it's engaging, but it doesn't mean the power is going through. So we always want to check on our start relay to make sure that we got power on this side, and when we energize it, we got power on this side. And the other thing is making sure that we have a good ground. Okay, when we're checking our voltage from our ground to our ground, this is what we're doing here. Again, we're checking to make sure we have very little resistance in our ground circuit. We're going to check each of our components. So if we find that we have an issue, we can go through it. How we do it, whether we start here or start here, it doesn't really matter as long as you find out where the problem is. Now, don't overlook a seized engine. So bar the engine over. If it's sat for a while, maybe it's we've got some oil or some fuel that's filled up the cylinder. Maybe we got a head gasket that's gone, and that's the problem, not the starter. So bar the engine over to make sure that it still bars over. Another thing that you got to take a look at is on the older type starters that don't use a ground stud on the end of the starter. They used to rely on this mating surface for our ground. So the power would go through the starter and into the case, and then this was our ground. If this got corroded, it would create resistance, and we wouldn't get proper current flow because it would be creating too much of a resistance. So always check that out. Now, what we want to know is on a starter, so you're going to have to look up specs. So for a 42 MT starter, type 400, and again, pay attention to the rotation because it's either clockwise or counterclockwise. And we want to know what our free spinning speed is. So what we're going to have is we're going to have a tachometer set up on it. We're going to have a carbon pile. We're going to check the current draw and see what our free speed is. So when you find your spec, you can find that the minimum of this one here is 5,500 to 7,800, and what our current draw should be, minimum of 100 amps at 10 volts. It also gives our specifications for our solenoid. So maybe we have an issue with the solenoid and it's not pulling the solenoid in properly. When we have our starter out, we should always make sure that the starter armature still spins, that this clutch works one way and freewheels the other way. Anytime we're disassembling the starter, mark it, especially for the nose cone, because the nose cone can be oriented anywhere it wants on the starter. So as we're taking it apart, one of the things to be very careful of when we're undoing this cover, this plastic is a thing called Bakelite, and it's fairly fragile, so if we tighten up this nut or we strip this, we're going to break the Bakelite, so be very careful with that. There's this bolt here, so this is our B terminal, this is our M terminal. So this has a strap that goes down to the field coils that are inside the start motor. And then we have our G terminal, and on the other side we have our S terminal. So when we're taking apart, again, our ground, to take this back cover off, you have to undo this, take this one off, and then you can undo these bolts and pull the whole back cover off. When we're removing our solenoid, we have to remove the strap that's onto our M terminal, take these 3 bolts out, and then we can slide this out. And what we're sliding it out of is the iron core that's in the middle. So taking the back off and inspecting all the brushes. We also don't want to overlook our crank protector. So this is what it looks like. And it's got the bimetal strip inside. So On the older ones, you used to be able to, there used to be a little bolt that held all the brushes together, and the new one, they're soldered together, so it's a little bit more difficult to change brushes if you have to. When we're taking our nose cone off, again, we're going to have 6 bolts, and you can't really see it, but there's a whole bunch of different holes around here, so we can turn this nose cone anywhere we want. We want to orientate it to the position that this part is not going to hit the frame or the engine. So when you're replacing a starter, you may have to reorient that nose cone to what the old one is. So once you've undone these 6 bolts, you can pull this off the front, and you end up with your drive here. Then we have to remove this cap, and in behind this cap there's a nut. We have to undo that nut. Now this is one of the adjustments that we have to make when we're reassembling the starter motor. And what it does, it determines when this is fully engaged, how far this is going to come out. Because what we don't want is, we don't want that drive to come up and hit this nose cone, because it'll break the nose cone off. There's that much torque when it pulls it in. It will break your nose cone, and then you'll jam up your engine. So once we get that all disconnected, we can pull the pin. And once we've done that, then we can pull that front housing out where our brass bushing is inside here. So this is all come apart. Then we can go through and we can do the inspections. Now, be very careful when you're taking your drive off. So on the end, there's a little place for a snap ring. Now that snap ring is not a normal snap ring. It looks like just a piece of wire. Well, it fits inside of here, so don't force it apart. They're really tough to get back together again. We don't take our pole shoes out because, again, we don't have the proper tooling to separate this so we don't squash it. Because if we do, then the armature is not going to spin inside, it's going to jam up. Cleaning our commutator before we go in and check it, again using a brass bristle brush, and making sure that our mica is undercut enough that the brushes are going to touch the commutator bars. We also want to check to make sure that our armature isn't bent. So we're allowed to have 3 thou of runout, so total indicated runout of 3 thou for that. The other thing we want to check for is shorts. Now this is called a growler, and a growler is used to check for any types of shorts that are in the armature. And what will happen is the hacksaw blade will start to vibrate and bounce as we're rotating this around, rotating the armature around on the growler itself. If a short is there, the hacksaw blade will start to bounce. If we have shorts, we'll see some arcing on the commutator. The other thing we want to check for is make sure we don't have any of our segments that are open. So on the growler itself, you'll have a little light here, and on your probes you can go around and you can check for any of them that are open. We also want to check to make sure that our commutator bar isn't grounded by taking a meter and putting it from the commutator bar to the shaft. And again, it should be open. If it isn't open, we got a short in there to the ground side, our starter motor won't turn. When we're cleaning up our armature, if it's reusable, we can use 200 grit sandpaper on there to polish it up. Now one of the things we got to pay attention to is if this is grooved at all where the brushes have worn in to the commutator, we can't reuse it. We can send it out and it might be able to be cut, but chances are that once the grooves are deep enough, it's no good. The other thing we have to do is let's just say we sand it down, they use an insulating material in between each of these bars. We have to make sure we undercut. In some of the older ones, they used to use mica. what works really good is just a hacksaw blade in here and undercut that so that the brushes are only contacting the bars, they're not contacting the insulation. If we're replacing the bushings in the nose cone, again, having a special adapter to force these bushings out and make sure that we change the wick or re-oil the wick that's in there to keep that lubricated. The center bushing, because it doesn't get lubricated, change it also. When we're taking a look at our brush holder, again, we have 2 negative brushes and 2 positive brushes. We also want to check our springs for tension. So because they're spring steel, if the starter motors ever got extremely hot, it'll take the tension out of the springs. And if the springs can't force those brushes in against the commutator, we're going to lose contact. So there is a spec for what the spring tension should be. Then inside the starter motor housing itself, we want to check our field coils. Now what we're checking them for is ground. We want to make sure that there is no ground, that power only goes through the field coils and then comes out the brush contacts. We want to check our overcrank protection switch again. We hook our meter up to it, we take a heat gun, heat it up, and watch to see that it opens. The other thing we want to check is our start solenoid. So we have our battery terminal, our motor terminal, our solenoid, and our ground. So if you remember, when we energize our relay, this sends power down to the S terminal. It energizes both the hold-in and the pull-in at the same time. The hold-in gets its ground here. The pull-in gets its ground off the M terminal. So what we're doing, again, we've seen this picture in the last one here, and I've got a little demo I'm going to show you what happens internally. So again, as this gets energized, this pulls this in this way. Okay, both of these coils are energized. As soon as this disc, and this is what the discs look like, it's just a copper disc. Once this pulls in and contacts between our B terminal and our M terminal, our pull-in winding is going to drop out because it has power on both sides, but our hold-in winding is going to hold this in as long as the switch is closed. Okay. Now on the back, where this disc touches, it contacts our B terminal and our M terminal. And you'll notice that there's quite a bit of arcing, because what happens is as this makes contact, it wants to arc. Now on the older ones, you used to be able to, you can undo this nut and you can switch this around to a brand new copper disc. On the newer ones, they rivet it so you can't do that, so you can't fix that out in the field. We also want to check our overrunning clutch and make sure that it moves in one direction and locks in the other direction. We want to check the insulation on our field coils to make sure that it's not getting baked off. And most of the times this is covered, you can't see all of this, but you'd be able to see any amount of heat that's being built up inside there. Now on our pole shoes, and this is important, if you ever take these apart, you got to remember which way they go. This is the short side, this is the long side. So it always rotates from the short side to the long side, and if you put them in backwards, it doesn't work properly. It'll work, but it just doesn't work properly. Now, this is where this little snap ring is. To get it back together again, this ring here has a little bit of an indented lip to it. So what it does is it looks like that. So when we clip it together, that steel ring stays inside there. So we got to make sure we clip this back in properly so it doesn't come apart. Now as we're going back to reassemble it again, putting the armature back in and getting the brushes set up against the armature to make sure that they're making full contact. Now this is a tool, I've never used it. It's for setting the orientation of the nose cone, and that's why we mark it, so that when we go to put it back together again, we have it oriented to the same position it was before we disassembled. Once that is done, we're going to make sure that our armature spins inside with very little resistance. Now this is the one setting that I was saying you have to set on these 42 MT starters, is as this gets driven out, we don't want this drive hitting the end of the nose cone because it will break it. So there's a specification for how far this can come out away from the nose cone to protect it. Going through and checking our resistance internally inside between our G terminal and our S terminal. And taking a look, anytime we take a starter out, always check the teeth that are on the flywheel. Now a 6-cylinder engine, which we deal a lot with on highway trucks, it will stop in any one of 3 different spots. So checking these to make sure that we're not wearing the teeth out or we don't have any broken teeth. If we're buying a new starter, count the number of teeth that are on this drive and compare them to the old one. Make sure they're the same size because they do come in different gear ratios. Checking our cables is another thing. So again, doing a voltage drop is going to check those. And that's it for the servicing part. And I'm going to go through on some of the other little things that we should be taking a look at.